In the next example, that will be example 6. We need to come up with the curve. Let's graph, okay, instead of sketching. Actually, let's do graph sketch again. The polar equation. R equals 2 cosine theta. Okay. Before we jump into our graphing device, let's see if we can pick up some values. Okay, make a little table, for instance, theta in R. Okay. And pick up some values from, let's say, 0 to pi, using the spatial angles. So we start with 0, and then let's go, what, pi over 6, pi over 4, pi over 3, right? And then we go 4 pi over 3, 5 pi over 4, 3 pi over 4, and I ran out of room. But it will be 5 pi over 6, right there in small letters. This is 2 pi over 3, thank you. 2 pi over 3, 3 pi over 4, 5 pi over 6. So for 0 we have 2, okay? So now here beside, we're going to sketch it. So we start with, this is the angle 0. So this is the polar axis. Okay, 0, 2 will be right here. And then pi over 6, then cosine of pi over 6 is what? Square root of 3 over 2. So this would be square root of 3. Okay, square root of 3, pi over 6 is 30 degrees, is right here. And square root of 3 is about 1.7. So if this is 2, we are looking at this point right about pi over 6 is right here. Okay, so this is R equals 2 and theta equals 0. This will be square root, R equals square root of 3 and theta equals pi over 6. Pi over 4, cosine pi over 4 square root of 2 over 2. So this is square root of 2, which is 1.4. So it's a little bit, it's right here. So it will be square root of 2 and pi over 4. And then pi over 3 cosine theta equals 1/2. So 2 times 1/2 is 1. So it's about 60 degrees. So we're looking something like that. So this will be 1 and pi over 3. And then we are diminishing. At 2 pi over 3, the cosine is again 1/2. So we are back to 1. No, at pi over 2, we missed pi over 2. That's what I was missing. At pi over 2, then we have 0. So this is, subtract this. This is incorrect. Okay, this point right here at the pole, this point corresponds to 0 and pi over 2. What happened in the second quadrant? the same values but negative. Okay? So, meaning that in the second quadrant, as we go to angle equal here, we need to go in reverse. So, we're going to see points right here, like so, going back. And the end result is, this is a circle. Okay, so for instance, this point corresponds to negative square root of 3 and 5 pi over 6. This point will correspond to negative square root of 2 and 5 pi over 4. And this point corresponds to negative 1 and 2 pi over 3. So this would be negative 1, negative square root of 2. This would be negative square root of 3. Okay, so we end up having a circle like that. So turn out that r equals 2 cosine theta is a circle. Okay, where is the center of the circle? The center of the circle is, if we have 0 and pi over 2 here, and 2 and 0 here, the circle would be at 1. So, one part, so actually this question has two parts. So part A, this is 6, so let's do example 6b. So this will be 6a. 6b is prove that r equals 2 cosine theta is a circle So how are we going to go ahead and prove that thing? Okay. Okay, we start with, given that x equals r cosine theta, we get that cosine theta equals x over r, like so. Okay? So therefore, cosine theta, or x over r, actually, instead of this, let's write cosine theta equals x over r from the conversion, or actually this is the definition of the polar coordinate system. On the other hand, necessary, cosine theta is x over r, so, and r equals 2 times cosine theta, so we'll have r equals 2x divided by r, and r squared now equals 2x. Okay? That's what I was trying to get. Now, what is r squared? Come on, folks, talk to me. What is, when we do the conversion, how we convert r squared? Right. So x squared plus y squared equals 2x. Okay? But we are not done yet, because if we'll do the following, if we'll write x squared minus 2x plus y squared equals 0, and now we'll do a little algebraic manipulation. We're going to add 1 to both sides. Okay, so add 1 to the number 1 to both sides. And now you get x squared minus 2x plus 1 plus y squared equals 1. And what we have here is x minus 1 squared plus y squared equals 1. And this is a circle center at 1, 0. Okay? So this is the equation of a circle with radius r, with radius r equals 1 and center at 1, 0, right? Because it's x minus 1 squared plus y minus 0 squared equals r squared. And that completes the proof. So if you convert where we started, r equals 2 cosine theta to Cartesian system, then the conversion will yield x minus 1 squared plus y squared equals 1. And you'll have this type of activity in your homework.